We start chapter 2 off with organizing qualitative data. Remember, qualitative data was data that has characteristics that we can compare. We turn to quantitative data when we have numbers to do with those data that we can compare. Adding and subtracting means something with qualitative data. Quantitative. Qualitative is pretty much everything else. So, the first type of display that's helpful when organizing qualitative data is called a frequency distribution. A frequency distribution simply lists each category of data and the number of occurrences for each category of data. It's kind of like a tally of data. So we're going to be receiving raw data, which is just like a table of stuff, table of information. We need to organize it in some way. So frequency distribution simply just counts the different type of data we have. So if we look at example 1, it says a physical therapist wants to determine the types of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body part requiring rehabilitation. We're going to start off by doing a frequency distribution of this information. So let's look through here. Let's make a frequency distribution and then eventually a relative distribution or relative frequency, which comes later. What are all of the things that you see in this table? We're going to organize it in an organized fashion. The first body part I see listed on this table is the back, and I see it at least one time. I'm starting to read this right here, and I'm going to go straight down. So what's the next body part? Wrist. And I'm going to put one tally because we've seen wrist one time. What's next? Elbow. We'll put a 1. But then we have back. So I'm going to put a second tally next to back. See how we're just tallying them up? After elbow, we had back, and then we have hip. And then we have neck. Then we have shoulder. Oh, and then back, so another tally up there. And then the knee. And then the hand. And we go up to the next column. It says back, and then back, and then back. We have shoulder, knee, knee, shoulder, back, knee. I got lost. Back. And then another hand, and then a groin injury. And then another back, and then another shoulder, and then the hip, and then the knee, and then 3 backs, 1, 2, 3, and then another wrist. Woo! Yep. Everybody should start stretching now while you're young, and keep your abdominals strong so you don't have back injuries as frequently. Side note. Okay, cool. So that's a tally. The actual frequency is just literally the number from the tally. So how many people came in for a back injury? 12. How many came in for a wrist? And then 1, and then 2, and then 1, and then 4, 5, 2, and 1. This is a frequency distribution. It's pretty obvious to see in a frequency distribution, the most common body part needed for rehabilitation is the what? The back. That's a frequency distribution. Check. A relative frequency, which usually comes right after doing a frequency list, a relative frequency is the proportion or percent of observations within a category and is found using the formula relative frequency equal to the frequency, bless you, of each data point divided by the sum of all frequencies. I just went up, by the way. This is the definition back up at the top. So we can find the relative frequency, which is like 12 divided by the sum of all frequencies. Now, it is a good idea, and I guess I didn't say this out loud, when we're doing a frequency distribution, it is a good idea to add up the frequency column to make sure that it equals the number of observations. We know that this physical therapist had a random sample of 30, so we always want to do a quick little check to make sure that this still adds up to 30. That way we didn't miss one. 12 plus 2, 14, 15, 17, 18, 22, 27, 29, 30. Check. So when we're doing relative frequency, all we're really doing is 12 out of 30. Good thing you have a calculator today. Give it to me as a decimal. What is 12 out of 30? .4. And I'm going to write 4 decimals on purpose. Sorry, Jimmy. Because later on our numbers are going to get very small, and so we're going to need some more decimal places to make this make sense. So for our wrist, to do the relative frequency of the wrist, since we're now checking relative frequencies, the wrist was injured 2 out of 30 times, which is what decimal?
0.6 repeated.
0.06 repeated, I think?
Yeah.
Yep. Do we see how I'm getting these? One more time all together. If we were checking the elbow's relative frequency, this is 1 out of 30. On your calculator, 1 out of 30. 0.03 repeating. Do we see the math involved here?
Yeah.
Can we go quickly through it?
Yeah.
Okay. To do, again, 2 out of 30 we've already done is 0.0667. 1 out of 30 we've already done that is 0.0333 repeated. 4 out of 30 is 0.1333. 5 out of 30 is 0.16 repeated. Again, 2 out of 30, 0.0667. And 1 out of 30, 0.033 repeated. These numbers, they're decimals, yes, I know that, is the relative frequency out of these 30 observations for each each body part, data point. It is a good idea. It's kind of hard here because we rounded these numbers, but that's why we kept so many. If you added up all of these relative frequencies, we should sum to 1 because it's all out of 30. So it's all out of the whole, which would add up to 1. That is a frequency list, frequency distribution, as well as a relative frequency distribution. Questions? Cool, let's keep going. Because yes, seeing a chart is great, but we can also have qualitative data and eventually quantitative data displayed for us in pictures. So there's different kinds of pictures of data that give us powerful results when we're looking at qualitative and quantitative data. The first one we're going to look at for qualitative data is a bar graph. A bar graph is constructed by labeling each category of data on either the horizontal or vertical axis and the frequency or relative frequency of the category on the other axis. Rectangles of equal length are drawn for each category, and the height of each rectangle represents the category's frequency or relative frequency. We're going to use our highlighters because they're thicker highlighters, and we're going to use those as if they're rectangles. So we're not actually going to draw rectangles, but your highlighter, if you use it correctly, will give you a rectangle. So we're going to take the same data, which does mean, unfortunately, you're going to flip back and forth on this page, and we're going to take the frequency and relative frequency from the table we just made on page 1, and we're going to make them into bar graphs. This first one is the frequency distribution. The second one will be the relative frequency, which makes sense because this one goes all the way up to 12 or a little more. And this one goes all the way up to 0.4, which were the highest of each relative frequency and frequency that we had. So flipping back and forth, so sorry, kind of annoying. What is the frequency of the back? 12. So you're going to take your highlighter and you're going to make a line for 12. If you use it correctly, it'll end up looking like a rectangle. Mine is rounded, so it's not as accurate. But yours, you can make it a rectangle. How many for the wrist? 2. How many for the elbow? 1. Do you see how we're doing this? The hip had 2. The shoulder had 4. The knee had 5. The hand had 2. And the groin and the neck both just had 1. That is a frequency distribution in a bar graph. Let's do the relative frequency this time. So if we're looking at the relative frequency part of our table, what was the relative frequency of injuries to the back? 0.4. So we're going to draw our rectangle all the way up to 0.4. What was the frequency of the wrist? 0.6. So we're going to go like this. The elbow? 0.3, so even smaller. 0.03, I guess I should say. The hip was 0.06.
Yeah.
The shoulder was 1.3. The knee was 0.16. The hand was 0.06. The groin and the neck were both 0.03. I'm going to make mine look a little nicer since these are the notes that y'all will look at later. But if you use that highlighter correctly, it will already look like a rectangle and you won't need to outline yours unless you like to do extra. Comments, questions, concerns while I'm filling this in? So one commentary that you might have here is that these bar graphs look good, but they're like all out of order. Wouldn't it be nice if they were in order from greatest to least?
Oh, yes.
In fact, that is a type of chart itself. So a bar graph whose bars are drawn in decreasing order or frequency or relative frequency, that is called a Pareto chart. It is literally the same information we have above. This is our relative frequency, so our blue. Okay, it's the same exact information, except that now instead of just being in the random order we decided out of the raw data, we now have it in order from least to greatest, which does allow you quickly to draw conclusions. You can more easily see that the elbow, groin, and neck are the same, that the wrist, hip, and hand are the same, and that by far double the knee is the back, more than double. So it allows us to draw a little bit of confusion. So you can order them from least to greatest. It's just a different kind of chart. Sound good? The next type of way you can organize the qualitative data is called a side-by-side bar graph. It is exactly what it sounds like. In a side-by-side bar graph, you use them to compare data for two different sets of data for the same variables. Data sets should be compared by using relative frequencies. This is important right here. We need to be using relative frequencies and not frequencies, because different samples or population sizes make comparisons using different frequencies difficult or misleading. So for example, let's say this is actually a good example. There are 3 juniors in this class and the rest of you are seniors. So if I split you guys into juniors and seniors to compare your results and said 2 juniors want this while 5 seniors want this, okay, that might actually be the same percentage of each class, that same relative frequency out of each class, but it looks wildly different because there's just not as many juniors in this class as there are seniors. So we use the side-by-side bar graph with its relative frequencies to do this. So we have an example 4. Data in table 4 represents the educational attainment in 1990 and 2017 of adults 25 years and older who were residents in the United States. The data are in thousands, by the way. We're going to draw a side-by-side relative frequency bar graph for the data. So what we know is that if we looked at all of the people we studied in 1990, we surveyed more than 158,000 people. Of those people, 39,344, it's in thousands, people were not a high school graduate. So if we wanted the relative frequency of that, we would just do that math. We would do 39,344 out of the total, which gives us our relative frequency of non-high school graduates out of the population that we surveyed in 1990. Notice that the population size is bigger in 2017, so we can't just compare frequencies, we need relative frequencies. I'm going to actually write this smaller because I needed to zoom in before I did that to make this actually fit. So 39344 out of 158,870. And as a decimal, let's keep 4 decimals. What is that number?
0.2476.
That is the relative frequency of people who are not a high school graduate in 1990. We're not going to show our math on all of this because that box is too small, but just so later when you're looking back, you can see where we got it from. How about in 2017? Well, in 2017, 26,582 out of the surveyed 221,251, which what is that's relative frequency?
0.1201.
So even though we can see that the frequency went down, it's shocking how much the frequency went down when you take it out of the population, because we actually surveyed more people in 2017. So what I want us to do is I want us to finish filling out this table for the relative frequencies of people in 1990 and the relative frequencies of people surveyed in 2017. I'll give you some time to do all the calculations, but you don't need to show me the calculations anymore as long as you know where it's coming from. I want you to just write down those frequencies for me. I'll give you some time. After computing all of these relative frequencies, we should end up with a table that looks something like this. This is kind of hard to read, which is why a bar graph of putting these numbers side by side of the relative frequencies would actually probably allow me to make better conclusions about the data in general. So what we're going to do for a side-by-side graph is we're going to take the numbers that we got out of that table and we're going to graph them side by side. We're picking 2 colors here. You probably can already tell my color scheme. 1990 for me is going to be in green and 2017 is going to be in blue. And I want to graph both data points for each category at the same time next to each other. So in 1990, our number for the relative frequency of people, bless you, who are not high school graduates was about 24. So here's my ish 24 line. And in 2017, switching colors, we're down to 0.1201. So it's about here. So we can now see, comparing these boxes that we drew, these rectangles that probably look nice with just your highlighter and no need for the bolding, unlike me, we can see a drastic change. Let's keep going. For a high school diploma, in 1990, the number we had was high school diploma at 0.2999, which is almost to 3. So we'll almost, wrong color, Miss Quigley, we'll almost reach 3. And in 2017, stopping at a high school diploma was about 0.2713, so pretty close. For some college but no degree, in 1990, it was 0.18175. Wow, saying numbers is hard today. 0.18-ish is here. And in 2017, some college no degree was at 20. Did I say the right number? 18? Yeah.
Yep.
20. A little bit higher. Associate's degree in, what year is that? 1990. Why can I not remember that year? Was 0.0616, so it's just a little bit higher than the 0.05 line. And in 2017, it's 0.08. So a little bit higher than that, not quite to the 10. In 1990, bachelor is 0.13, so we're a little bit like here. And in 2017, 0.19, so just underneath 20. And your graduate or professional degree in 1990, we're rocking it at like 0.07. So again, just over 0.05. And in 2017, we've jumped all the way to 12. Obviously, the data in the relative frequency table is helpful to see because we have the actual numbers here. I'm not the best artist in the world, so mine's, bless you, decently inaccurate, but we can eventually use technology like Excel or things like that to make these graphs and charts look really good. But we can draw some general conclusions even from my human error style side-by-side bar graph. Some of the general conclusions: the relative frequency of adults who were not high school graduates in 2017 is about how much of this one? If you were to estimate it, about half. In 2017, a blank proportion of the adult population has at least a bachelor's degree. I would just say a much higher proportion. Because look at this difference. We have a much higher proportion in 2017 in bachelor's degree than we did in 1990. However, the proportion of the population with bachelor's degrees has not doubled as the frequency did, like the numbers in the table suggest. An overall conclusion is that adult Americans are generally more educated in 2017 than they were in 1990. We can see the increase in the data. Is somebody finding my iPhone? Is that what's happening? I keep hearing the Find My iPhone sound. So we've had bar graphs to show our relative frequencies. We've had side-by-side bar graphs to show our relative frequencies.
Oh, no.
What, did you flip the paper over? The third way that is nice to see data for qualitative data is in a pie chart. We haven't thought about a pie chart in a minute. Pie charts are typically used to present the relative frequency of qualitative data. In most cases, the data are nominal, but ordinal data can also be displayed in a pie chart. What am I hearing? All right, so a pie chart. We've seen these before. A pie chart is a circle divided into sectors. Sectors is like a pizza pie slice. Each sector represents a category of data. The area of each sector is proportional to the frequency of the category. So the area of the sector is proportional to the frequency of the category, which means we need to figure out what proportion of an entire circle each of these relative frequencies would take up. So math. So the data presented in example 4, we've copied it here, and in fact, I found the relative frequencies already, which we did on the other page. Surprise, the answers were here. We're going to find the degree measure of each sector. So we had the frequency that they gave us. We found these relative frequencies, and if we want to put these into a pie chart, we need to know what percentage of an entire circle we're going to take up. If you're going around an entire circle, how many degrees is that? And if you only want 0.1201 of it, we need to know how much percentage that is, or what degree we would use. So if we do the relative frequency 0.1201 times 360 degrees, go ahead and do that one for me. 0.1201 times 360 degrees.
43.236.
Yeah, we're knocking around this one because we can't graph that accurately anyways. 43 degrees. So when we draw this section of the circle, we're going to make it as close to 43 degrees as possible, which is why I had you pick up a protractor when you walked in. If you didn't, you can get it in a second. Let's finish the math here. We're multiplying, again, the relative frequencies by the whole circle, which is 360 degrees. If you do the second one, how much degrees should you have for the sector representing high school diplomas? 98. We'll round up. Okay? You continue to do this math all the way down. You fill out this chart. We would do 0.2039 times 360 degrees, which is 73 degrees.
Can you run into the whole number?
Yeah, just because like we're not going to graph that accurately. If we were using technology to do it, I'd have you keep the decimal degrees, but We're using a protractor and they only have whole numbers on it. Which means we're giving ourselves some error in this drawing. We'll get to technology usage later in this course. This one's 31 degrees. This one's 71 degrees. And this one's 44 degrees. Now this is hard for me to show you because I really don't have a way to show you the protractor I'm holding with my hands at the same time, and also my iPad screen is very small compared to your paper. But what we're gonna do is we're gonna take these degree measures we have for each sector and we're gonna try to get them to be as accurate as possible in the circle. First things first, you're gonna eyeball the center of the circle. Ish. And you're gonna draw, I like to start going like as if it was a real unit circle. Just give me a positive x-axis, which if those words don't mean anything to you, that's fine. I'm teaching trig in the rest of my classes, so that's the positive x-axis. You're gonna take your protractor and you're gonna put the little, you see a little circle? See a little circle that's clear? You're gonna put the little circle that's clear on that dot, and the line that is sticking out right from next to the little circle on that straight flat line you just made.
Is it 70 or 71 on this one?
Okay, I don't even know if I can do this on my iPad because this protractor is so much larger than my iPad screen. But you're gonna put that little dot down and line up the line. And on the outsides or the insides, you're gonna look for the acute angle of, I forgot the degree already, 43 degrees.
Miss,
Yes?
you can zoom out on your iPad. And put the protractor on the screen.
Like this?
No, zoom.
My protractor is larger than my screen.
No, I'm talking about like zoom out. And
Oh, on the TV?
Wait, I'm confused.
I can't write on the TV. Okay, let me see if I can. I can't even pick up the protractor now. It's stuck on the screen.
Oh my God.
Okay, let me try this way. Oh, this is a mess. If I was doing this on the TV screen.
Miss Clearly, you can write your screen.
Y'all are so right. Oh my gosh.
Oh my
What a
gosh,
mess.
Miss.
Okay, well, you get what I mean.
Did you though?
No, I get it. So again, don't make me pick that protractor up off the floor. We already saw that was a disaster. So I'm measuring with my protractor. I made a line at about 43 degrees, and I'm just going to close up that circle, which I have to move mine around because my protractor is too big. So then we make this pizza pie slice. Just do your best. Now we're gonna have, what's up?
Why don't you just take off the case?
I've tried to take it out of the case and I broke a nail doing it once, so we're just gonna leave it in the case. My nails are more important. This section represents not a high school graduate. We want to label what this data is and put the percentage, just in case your sector isn't quite perfect. And now I can see the mark I made on the TV. Does it erase with like an eraser?
Yes, it does.
I don't ever write on the TV with an eraser.
Why?
Because it's a large piece of equipment that I'd have to pay for.
Yeah, but it's what marker.
Okay, if we go to do this again, the next marking we have is 98 degrees. You can see me over here. I'm going to sit down and make it easier on myself. Okay, you turn the protractor now so that the little dot's still on the little dot, but now your line is on the one you made to close the not a high school grad section.
Okay.
So we're having now this time 98 degrees, as close to it as possible. So I've got my protractor laid on that line. I'm going to approximately 98, which is like here-ish. And then I'm going to turn my protractor and close that sector up.
Do you want us the line that we had before?
The one that you used to close it. So like, look at the board, this one. This section is education made it up to a high school diploma. And this was 98%. I'm sorry, these should be degrees. What am I even doing? Not percentage. I got all flustered using this protractor. Oh my gosh, I messed up this number. So yes, now I'm gonna work on my own because honestly talking and doing this at the same time is really hard. But work with your neighbor or call me over once I'm done and I will help you. Let's go all the way around the circle for every sector. Okay, my fumbling aside, do we see how this works? And I know the protractors are mid at best. But yes, we see the entire distribution of the frequency for these different degrees out of all of the sample that was chosen for this particular thing. Now, a great question that should follow up learning about bar graphs and pie charts is, when should we use a bar graph versus when should we use a pie chart? What are some thoughts you have on that? When would it be more beneficial to use a bar graph versus a pie chart, and vice versa? What do you get out of a pie chart that you don't get out of a bar graph?
You get a visual comparison on the size of the group.
The sizings of the groups. Out of the entire one thing, like out of the study in 2017, you get to see a size comparison of the divisions of all possibilities for this qualitative variable. But if you really wanted to get into the nitty-gritty, like I know we have ours listed with the percentages, but if I were to ask you, without those percentages listed, how close together visually some college no degree and bachelor's degree are, would you really be able to tell the 2-degree difference in these two sectors? No, especially because I didn't draw them perfectly. But that's when we would go back to the frequency distribution or the bar graph, because that would show you more accurately the actual numbers instead of comparing its percentage out of the whole. So pie charts are best used for comparing parts of a whole of one data variable. But if you're trying to compare parts to each other, your bar graph is going to be much better. And in fact, because the bar graph can be side by side, you can compare two separate data entry points, two separate studies in one. A pie chart cannot be two studies put together because it's always parts of a whole.